So like I was saying, we'll go over the assignment quickly. Then I'll show us what we're going to be doing for the project. We'll discuss the data, discuss what the expectations from the project are. So I'd like everyone to really pay attention to that bit. And then tomorrow, Jumoke is going to send you guys the data set and the project, and also your groupings to work on it. So we have quite a bit to do today, right? Yeah, so I'm just creating, so we're trying to do number one. So I'm just trying to create the database and put in all these tables. So I can use the wizard. Do it again. Good. So anyway, once I complete the database, I'll show us. So in my case, I think the approach was kind of to clean the data up a bit. And I'm just doing that because for the project, you have to make sure you check the data first and be sure. That it's in a format that works for your project. Transactions, open, next, finish. Right, so we refresh this and we can see all our tables, right? Right, so I've created these tables. Oops, sorry. No. Can you see my screen?
Yes, we can.
All right. Okay, so this is a database orders 2 that has all the tables. I'm sure everybody has done that. So if we first, I like to inspect the data, right? So we did select star from color. Effect of them, right? So that's color. That was what again? Food. There was person. Stores. And transactions. Transaction action. All right, so if we run all of this, we'll see all the different tables. So automatically we can see, transaction ID, store ID, person ID, items, quantity, price. For this one, we have store ID, store name, person ID, first name, last names, person ID, food name. So you can see all the connections between the tables. By just looking at it, you can already start visualizing the schema, right? And what tables you can connect to and with what, using what fields. So let's see. What does the first question say? It says, create a list of transaction ID, store name, person, full name, items purchased, quantity, and price, right? So for that bit, we're simply just fetching all those items. Let me just move this to the side. Right, and we're having to connect them from different tables because a different table has a store name, a different table has transaction ID, and full name, we can concatenate for that, and items purchased from transaction table, same with quantity and price, right? So let's just go in and so that'll be select. Transaction ID will come from transaction table. So let's say we're going to name that okay. What's the next thing? Store name. Store name will come from the store table, right? So let's say that will be S. Store name. For full name, we can do a concatenation. Let's make it big plus. So what are we concatenating? First name and last names, and those will come from what table? Person table, right? So P dot first name. Our usual space, last name. Right, so that will be first name, last, okay, it's S names, so first names. Remember, you have to make sure you have the field written the exact way, right? So first names, last names. And we can call that, give it an alias as full name. You can put the as, you don't have to put it, you can just say full name as well, it's fine. What's the other thing? Items purchased, quantity, and price. Those will all come from the transaction table, right? So T dot items purchased. Where's the transaction table? So that will be items. T dot items. T dot, what's the other thing? Quantity. And lastly, T dot price. Right. So we're getting all these from a bunch of different tables that we have to join. So I'll say from transaction. And we're joining the others. So what are we going to join transaction with store on and with person?
ID.
Anybody? On what?
ID.
Right, so person ID and store ID. Because the transaction table has both person ID and store ID. So with these two, we can connect the table to store, or we can connect the table to the person table, right? So we can say join person table, we can call that P on P dot person ID is equals to T, transaction table now, dot person ID, right? And same for store. I'll just repeat what we have above. So join stores. How's that table written? Stores. S on S dot store ID equals T dot store ID. Please be following in case I make typos. I just did one. Right. So all good. This should be it, right? Unless there's any small typo, this should be, yeah. So this is just, this is just a reminder on how to link tables, right? So I'm sure everybody got this right. Any questions? Someone in the chat. Okay.
No, the text is clear. So
I saw someone say yes at 8:01 p.m. That was long. So, okay, I see that everyone is quiet. So it's like we all know this stuff. So let me just skip to the tougher ones. Is there any tough one even? So creating view, remember, is just to say create view as and repeat the query. So I'm not going to bother doing that. Right. So just create view. You just add create view as, then put the table name, view name. Right. So that's straightforward enough. So the third thing is get the total number and total amount or total price of items purchased by person and by store. Does anyone want to share what they did for this question? Anybody? No takers. Okay, let's go. So here in this case, they said total number. So we already know we're doing a sum. Okay, ID, please go ahead. I cannot hear you clearly. Can you guys hear him? Is it just me?
no, we can't
Hello,
hear
can you hear me now?
Yes, perfect.
Yeah, I was trying to find my file, but somebody has posted it in the chat already.
Okay, their solution. Let me see. Okay, someone included counting items as well. Let me just run Sarah's code. You used all the same variables, right? Let me run your code and see what it gives. Right, so Sarah's code gives person ID, store, total items purchased. So this is like the count of items, right? Yeah, I see count items. Total amount purchased, which is sum of price. Okay. Nice. Any other approaches? Okay. Yeah, I think this works. I would have just added like ordering it. Let's see. Yeah. So this, say again?
Yeah, so please you tell them about order by. We didn't discuss that.
Okay, so maybe this is a good time to discuss it then. So order by just orders, it's just like ordering your data. And order by takes numerical order and also alphabetical. So if you did order by in the text column, it will order it by alphabetical order. So order by just, you can see the initial query I ran just had all the information, but the way it was presented, like you have person ID, and it just comes as they appear on the table, right? So you have this person number 8, bought at Target, number 10 bought at Target. So it's ordered it by default by the store name. But I felt it was a bit more intuitive to have it ordered by person. So you know, okay, there's this ID, we know this customer, and the person bought at this store, then you move to the next customer. Depending on your business use case, this is also fine, right? It may be that you're doing an analysis at store level and you want to say, okay, so Target, who bought what in Target? So Target had, 5 different people that purchased and it was person 10, 9, 2, 1. So it depends. So, but if you want to order by a particular column, you just use order by plus the column name. And this automatically orders in ascending order. And to do it in descending order, you just use this DESC. So if we do it this way, then it will order starting from the largest to the smallest. So you can see 10 before 9, before 8, and 7. So just one more thing, ordering by. So hope that makes sense.
Yes, and Shekinah, I wanted to ask this total number and total amount, is it not supposed to be sum? Like, does it give the same answer? Okay, sorry, that's what I want to ask. She is question C that you just did.
Yes, this is question C.
Because I was just looking at what ID posted. Yeah, so when you say total number, is it count or is it sum?
So total number will be number. With count, you have the number of transactions. With sum, you have the number of items bought. So it's really an interpretation thing, but it will be different. Because in some cases where you have items, like 2 items, 3 items, like if you want the total number of items purchased, then you will be using sum. But if you just want the total number of like transactions, so think about it like at Walmart, right? The number of people that check out, if you're counting checkouts. But if you're counting items bought, then you need to count like what they actually purchased. And you're right, it will be different. We did sum. Sum would give us no, but we can't sum items. We'll have to sum quantity. For what you're talking about, you'll have to be summing the quantity, right? So it will be T quantity, because items are names of things, right? There you go. So this is summing the items purchased, right? You see, you can also do this ordering. Is that what this is doing? Yeah. Okay, anyway. So with this, you're summing the actual quantity. Remember the original table. So with transactions. So if you're summing quantity, you're summing the actual things they're buying. If you're counting items, then you're just saying how many different things did this person buy. So 1, 2. You're just counting the number of different items. So, but I'm open to both as being like depending on how you interpret the question. So D is what's the food type and color each person in the person table represents. So you're looking for food type, color of each person. So we'll be selecting what? Person, food type, color, and essentially what we're just joining will be like food and color and adding it to the person table. Because remember, I always like to run all the tables to show. So remember now we're joining food, person ID is common, we're joining color, person ID is common again. All right, so that'll be a straightforward query. We'll be saying select p.person ID. And for food table, we'll be taking F and food type. Color we'll be taking it from C. And we now have to join the tables, right? So from person P, join. So we join the first table, we can join food, call it F on. Once again, what was common was person ID, right? So p.person ID equals adjoining table food, so f.person ID again. So you see, once you know the logic of like how joins work, how you're linking different columns, right? All you have to do is just build your query like incrementally. The logic is the same for a very complex table, for a simple table, still the same logic, right? person ID equals. And make sure we're typing along, right? Because all of that is also like practice on the syntax and how to structure your query. Right. So so it's the food type, color type for each person in the person table represents. Right. So in this case, they want for each person in the table. So we want all the, remember to always be careful with your joins, right? So we want everybody's color or food type. So even if someone doesn't have a color or have a food type, we still want them. What if someone has only food type preference, but they don't have color preference? What if someone has only color and no food type, right? You still want to capture everybody. So if you just do a join, you're going to be excluding those that don't have both, right? So you have to always remember that. In which case, what kind of join would that be?
I think right join.
So if you do right with this first step, for example, remember what you have on the left is perfect.
Okay, I think in this case it will be left, but I was also looking at your table, like, do we still need to use the person table, considering that color and food already have person ID?
Yeah, so the trick or the nuance there is because you want each person. So just think about it like you're in a class, for example, and you have students and you're sampling everyone's food type, best food and color. So there's a separate table that just has everybody in the class. So like the class register. Then you now create a new table where you identify the person and the answer they gave for food. You have another table where you identify the person with their ID and you get the answer they gave for color. Now, some people, let's say you did this survey on different days. On a certain day, a certain student was absent. So on the color table, they are not present, right? But they have food. So it could be that some students didn't answer both. So if you want to get the entire picture, you want to have all your students table, which in this case is our person table. You're left joining food, so you can get everybody and their food preference. Those that didn't put food will have nulls, so they didn't answer. You don't have their food preference. And you left join, again, the color. So those that didn't have any color response, you have nulls in that case. If you just did it with just the color and the food table, then your universe is now only people that answered to either of those questions. And even then, right, you would have to do a full outer join to get every single person. Because if you did a left on one side, you would only get like the list of IDs would be only all the people in that particular either color or food table. Do you get it?
Yeah, I did. Maybe because it was a small data that I was able to look in and see that the color for the color, everybody had something, but the food they didn't have. So that way I did it that way. But now I understand what you're saying. Based on the requirement, we should first get people in the person. Okay.
Exactly. If you had a people table, in that case, you would want to use it, like just to make sure you have the total universe of persons. But like you said, in this case, it still works out, apparently, like if you did color. Because, I don't think that's quite true. Not everybody has color. Number 3 has color, right?
For food, the other one was food.
Okay, it's food that had every?
Yeah.
You see, food, some people don't have.
So I had like nulls too, though. I think 10. Oh my God, will you turn that off?
What you're saying is that, no problem. What you're saying is that everybody had one or the other. So if you did a full outer join, it would work. But you see that with the person table, you're able to just at once do all of it. So, okay, I see what you're saying that, okay, there's no ID 3. Wait. No, we need to add left here. So you see, this thing is all very logical. You see, I looked at that table and I knew like I was missing a person ID. So with doing it this way, with this approach, you're able to have all 10 IDs. So here there's a null. You saw when I did the first one, when I had forgotten to change this to left join, we didn't have this row. This row was missing because it was just a join intersection for those that have both. But doing it this way, you can see that, okay, this person only told us what their food type preference was. We don't have their color preference. and the reverse
Yeah.
cases.
Thanks.
No problem. So the last thing was list the full names, color, food type, and sum of items bought for all people that bought at Amazon and Target and bought between 1 and 4 items. Let's see who'll share their code for this question. So I'll run it. Check the chat. I'm sure someone has done that already. Mahitaba, has anyone shared their code for this question?
Yes. Cynthia just did.
Cynthia. All right, I'll run Cynthia's code. I trust Cynthia's code. Where does it store it? Right, so these are the names of people that bought. Let me see what you used. So you selected name, full name, color, food type, sum of quantity, and you called it sum of items. This is good practice, but I would usually recommend just having column names that don't have spaces, just so that when you have when you're trying to reuse a particular table, like if you try to reuse this table, each time you'd have to put like quotes to use it because of the spaces. Like you cannot say P dot some space of space items. So if you're trying to reuse this table, it's always better practice to just name your tables with underscores, like without spaces. But this still works. Like this is your final table, so it's fine. From person, join color on this, join food on this. So you joined all the tables and you did an inner join for all. Where store name is this? And T quantity. So I understand your approach, but the thing here is like you're doing quantity greater than 4 as a filter on quantity, right? But if you look at your transaction table, the slight challenge might be that. So 1, this person, so people that are greater than between 1 and 4 items. Now, the issue is that this person bought twice, right? So the question is trying to check people that bought at Amazon and Target between these numbers as a sum, like combined quantity purchase. So if you had someone that bought 1 here and 1 there, like this, your code would exclude them, right? Because you're filtering, each quantity has to be between 1 and 4. Between 1 and 4. This question is actually a bit weird. I think this should be between 2 and 4, because between 1 and 4 is essentially from 1 to 4. Okay, so it's excluding those that bought more than, right? Exactly. So the sum has to be between 1 and 4 for Amazon and Target for sum of items, right? So here I can see you've done it right to some extent, but you're summing T quantity here quite all right. But your filter here is now on just T quantity. So you're filtering at the row level and not at the sum level. Unless you did halving. So if you grouped by and wanted to filter on the grouping, then you would use halving. But sometimes, especially with these small data sets, sometimes they pan out to be quite similar. So what I would have thought, for example, would be first to select the same things. So I think you got your selection right. So I would say select. So full first name. I'll just reuse your code. So select full name, select C color, select sum quantity. Plus another thing is like they're saying some of the items bought actually. So it's that one that has like the text. So this should be items, right? But the challenge here is that first you want to have an inner table, right? That sums. I don't know if did we teach how to do subtables? But one way to do it will be.
Sorry to cut in.
Yeah, go ahead.
You're going to sum items and you want to aggregate text. Is that what you're saying in this query?
No, I'm going to do a sub query.
Okay.
Let's call this something else. Let's say item quantity. You'll see where I'm headed at in a bit. So let's say.
Sorry, just to cut in. What I want to verify is there any way on the table that we have a section called the item quantity?
No, I'm creating a subtable.
Okay.
Just 1 second. So because we want to filter on the sum, there are two ways. Either we do the group by with having, but we've already seen that in class. I just want to show us another way we could do it. So if we take each person, right, and sum their quantity, right, of what they've purchased. Let me just, so if you're taking person, you select person ID from your transaction table, right? So you take, select T person. So you want each person and you want the sum of quantities. So that will be sum of T dot quantity, right? And we can call that what? What's the variable I used above as item quantity? So item quantity, right? I'm just trying to show you guys like using subqueries. So we have item quantity. What else do we need? We needed, was it color? We use color out. Okay, so from, let's see, stores transaction first. T, and we join stores. S dot store ID. If we join that to transaction table to be on T dot store ID, I believe. So here we're selecting person ID and quantity. Like why we're adding these stores because we want to filter out two stores, right? So we're trying to get person ID and quantity. Let me put this on another line so you guys understand it. And let me just do tab here so it moves a bit. So I'm creating a subquery or a subtable, right? that has person ID and quantity sum, but only for these two stores of interest, which is Amazon and Target, right? So that we can filter out like only those sums for those two, right? So after joining, I would say where I'll filter on the store. So store s.store name. And there are two, so we can either say like or in. Since there are two, let's just use in. What's the name? How does it show on the transaction table? Sorry, stores table. So we're looking for Amazon and Target. So the names have to be in Amazon and Target. Amazon, right? Target. So where you have that and quantities. So between 1 and 4. So that's kind of like a trick question because there's no 0, right? Everybody made some purchase. So less than or equals to 4. And then now we're going to group them by the person ID. So we want this number aggregated at the person level, right? So t.person ID. So if we run this in a query, let's see what it gives. Sorry, it's not transactions, it's transaction. Right. So when we run this inner query, what this gives us is each person's ID and the sum of their quantities that they purchase, because we're saying sum of t.quantity, right? And these are only for the stores Amazon and Target, and where the quantity for each purchase is less than 4. So we filtered and then you've summed it back up. So if you go back to this transaction table, people have multiple transactions here. So for everything that's between 1 and 4, you take those and then you now sum it up. So that's why I was saying the answer that Cynthia shared will be slightly different. So this is the use of subqueries. Like if you want to do some querying on a table like that you've already filtered, so this is now what we're selecting from. So when we're selecting all of these, right, we're treating this as a table now, and we're going to give it a table name, right? So you can call this as, let's say, A. So this you're seeing here is now table A. So that's what we'll be making reference to. So that's why I put A.item quantity, for example, because I was building out a table that will have item quantity. And then we'll now be joining this table on the other things, right, to get what we're looking for. So now we have person ID, we have item quantity. We just need to add the name. We need to add the color and food type, and we know what to join those on using person ID. Does that make sense? So we can left join. So we'll do person to get all these P things. We need to have person in the mix on person ID equals to, now we're joining to this table. So A is now this table, A.person ID. So this is just to explain that you can create subqueries that will act like tables. You just create a subquery, you give it a name, and you can now build the rest of your code around that, having that in a subquery in this form, right? So we're still using the person ID in table A. So person ID. What else do we need? We need for color and for food, right? So we just repeat this. So left join food. That's F. F the person ID equals A. Remember, that's person ID. And lastly, we're left joining. What's the last one? Color. Let's see. C dot person equals once again A. That's our subquery table, the person ID. So this for P, full name, this for C for color, for F for food, and A gives us item quantity. Where did I use person ID ambiguous? Oh, sorry, I forgot the P here. You see how reading like the error message like takes you to exactly what's wrong. That error message said, can you see it's error code 1052, column person ID in on clause is ambiguous. So I know that it means I didn't specify the table to get it from. And in this case, it was here, I just wrote on person ID. I forgot to type the P, right? So from your error, don't just say, oh, I'm having errors. Or like read the code and like the error, it always points to what error you're making for the most part. So you see what this now gives? It gives us the full name. It gives us the color where there's none, it's null. Because remember, some people didn't like have colors. Same thing with food type. Some people don't have the food type preference, but then it gives us the sum of quantities for everyone for their transactions are between 1 and 4, and for purchases in Amazon and Target alone. So you see what we've done here is to use a subquery. If you run just the inner part, which is the subquery, this is the table it gives you. And you can now treat this query as a table, like you name it as A or as whatever alias you want to assign, fine. And then with that, this is now the new table that is A, and you can write your code as if in your database you had a table that was table A and had this exact amount of data in it. So subqueries are very powerful for very like complex code, and when you want to break your code down into steps, you can always use subqueries in this way. Do you have any questions? Okay, no questions. So for assignment two should go very fast, hopefully. So that everyone has the table BFN rentals, right? I think it has just one table, right? So we can use, I'll just start to use BF rental. So this is what the data looks like. We have ID, created that, confirmed that, checking it. So who did number 1? Could you put your code in the chat? Anyone else code to share? Let's go. Does anyone want to share the code?
You're in question 2, the first one of question 2.
Say that again. This?
You said question 1. Do you mean like?
No. Oh, sorry. I meant the first question of the second assignment. We're done with this now. We're done with assignment 1.
Okay.
So now we're here. So I just want someone's code. I know since Cynthia said Wahala, like no one wants to post. Let's go. Anyway, the first one says, find the number of canceled bookings per month. Does anyone want to attempt it, or should we just? Okay. So I know you guys did CTEs yesterday. So this is saying find the number of canceled bookings per month along with the canceled percentage. So one first approach would be to get the year and month first, right? And then convert canceled. We'll be able to use case when. Convert canceled to like ones and zeros so that we can sum it. It's always very helpful to go that way. And we can get that as canceled, right? And then we can get the total number of bookings, because to get the percentage canceled, you need total bookings and you need number of canceled bookings, right? So once we're able to do that, just walking us through the logic, then we can now group by year and month, right? And we can get the sum of canceled bookings. Anyway, I'll just, let me just solve it for you guys. We're running a bit low on time, right? So remember how you do your CTEs. You're using your width and you're giving it the name. So let's say canceled booking as, and then you put in your query. So for the first one, we want to get the year. Remember our table, like we have created that. So we want to get out the year, we want to get out the month. So let's say canceled booking as, and we call the name of the table. So let's come to another line and select. Remember the function, the list of a few functions we use. So year and created at, that's the column that has the years for that booking, the date for that booking. We can extract year from it, right? And we can call that year. What else we want to select? Month. So let's say month. Same way, you can also extract month from the same column created at. We can call that one month. What else? Now, to get the total number of canceled cases, right? We can say sum, and then remember our case one. We use that. We've used that a few times now, so I'm sure everyone's kind of familiar with it. So remember in this table, you have your status. Status has closing, it has closed, it has canceled, and we're trying to look for what those that are canceled, right? So we can say when our status is equals to canceled, right? Then let's say 1, else 0. So we're just using this binary designation so that we can sum all the canceled bookings easily, right? And then we can end this guy. So end. And we have to give that a name. And remember, we're summing all of this. So you can use your case when within your sum. So it's like sum of a, remember case when like creates a column, right? A field. And we can, the way you can sum any other field, the same way you can sum your case when. So we can call this, let's say maybe canceled, right? So this gives you a field called canceled. Then remember, we want to find a percentage. So we need our total bookings. Now it's quite straightforward to get your total bookings. And you can just say, if all your canceled is the sum of those that are canceled, then your total will be sum of, you can just put 1, right? And we can call that total booking. Are you guys still with me? So we're selecting all this from what table? The only table we have, obviously, from rentals. And then remember what the question says. It says per month. and per year. Like we can say it's per month, but we can also add per year, because otherwise each month will be ambiguous, right? It will be combining different months with different years. So we're saying from rentals, and we group by year. Hello. Orders. Where am I using orders? Okay, I didn't run my use rentals. So it's still running from the old database. Okay, there you go. So you see what we have here, right? We have the year, the month, number of canceled bookings, and total bookings. Total bookings is this sum. And so now, same way where we use subqueries, like we're saying so we've created a table essentially called canceled bookings that would have this data. So it's always helpful sometimes to run your inner query to see what will be in your table. So we now have this table that looks like this. So once we have this data now, we can easily expand it to get what? The canceled percentage, which should be straightforward. And I'm seeing in the chat, okay, so Mahitabel just shared a couple of useful date functions like year, month. So everyone, please download those tips from the chat. I'm checking on the chat as well, and make sure you have those, because those will help you, right? Okay, so now we have all these sums in our inner table, right? So we can now select. So one way to do it as well, just to expand, how we're thinking about this a bit, is to create a combined function that has one integer, right? That adds your year and your month. So remember here you have your years. So if you multiply this by 100, you're creating like 2 decimal places. And if you add your month, then you can have one integer single date. So I'm just doing that times 100 plus month as date key, right? So you can always go back to this code, but I just hope everyone is like typing along, right? And we also want to get the canceled, right? Now, something else we want to get is to get what? The canceled over total booking. That will give us the percentage canceled, right? So we just say canceled divided by total booking, right? But percentage is what we asked for. So we just put brackets and multiply by what? 100. And we can call that what? As cancellation what? Percentage or rate, or so cancellation rate, let's see. So this gives us the percentage cancellation rate, right? And we're taking this from what table? Cancelled booking. So this is the table that we created, CTE. And, I think it makes sense to have it ordered. I wrote ordered by date key. Right. So does everyone understand this? So we have our inner query, that is this, right? And based on that, we're creating a date key.
Sorry, Shekinah, I understand the first part, but up until where you say select year times 100 plus months, the date key, can you just take that part again?
Yeah, we'll do now. So what that does essentially, I just wanted to run it so I can show you. Okay. You can see. So we've created, instead of having year and month column, you can see a date key so this 12/2017. So this December 2017. This is February 2018, and so on. So this is just a very common way like of presenting date keys where you have year and month. You know, your YYYMMDD format. So just without the day, but with month and at integer level. So all we did to get this was, remember this inner table has year and month as integers. So you have 2018 and you have 12. So it's just a way to sum it. So that multiplying by 100 is just so that this would be 2018, 100. And so when you add 12, 12 just gets almost like appended to the number. So it's just so that we can have this final format as an integer. And many times in many big databases, you'd see date keys in this format as integers because it helps with like performance on running big tables. So this is that. I'll just introduce one quick thing. So you can see there's 4 decimal places on each of the numbers. There's this function round. So round just says round, bracket, what you're rounding, and then the number of decimal places to which you want to round it. So let's say 1 to the 1, and you close the bracket. So this is just to limit the number of zeros. Right, so this is now 1 decimal place. If you put 2, it will be 2 decimal places and so on. So hope this makes sense. Make sure you're coding along. Does anyone have any questions on this? Otherwise, we're really running late on time. First of all, is there any question? Okay, someone shared, okay, Maitabel shared the code as well. Any questions? Okay, since there are none, let's do B. So B says find the price. Once again, you have this per day, per booking, per things, right? So very simple. You just have to always like think about the logic first, right? So here it's asking you to find your city averages. You need price per day, per booking, and per checking location. So you're grouping by location, definitely. You're aggregating at location, at booking level. And you want percentage change between the average and the actual price per day per location. A bit unwieldy, but let's take it in steps. So first, the first thing you want to do is to create that price per day. And price per day, looking at this table, would just be what? Price per day will be revenue divided by the number of days. So if the revenue generated for 7 days was 567, then the price per day just has to be the revenue divided by days. Now, in some cases, we're counting half days, right? So for half days, it's like, if you say you have 1 half day or 2 half days, so you have to divide by 2, right? So this is 6 and half a half day. This is 3 and 1 half day, right? So how many days is 1 half day? Is 1 divided by 2. So everything in this column, you are going to have to divide by 2. I hope that makes sense to get the total number of days. So yeah, let's accelerate a bit. So first, of course, we're doing our CTE that has these half days. So we can say let's say call it a rate because it's this over this. Let's say car rental rate or car rate. And we say car rate as. Remember how you do your CTE, you do your column, and then we're selecting. Sorry, let me just do something. Okay, so with car rate as, I think my Isabel just shared a few functions, so feel free to also download those. You could check it later though. So we're selecting what? So in each case, we need the ID, the check-in city, because per city as well. And we need to get that rate. So the rate, we're just dividing revenue by half days, all right, to get the price per day for all the rentals. So let's go. That'll be, let's call rental table R. So ID. We need check-in city. How's it spelled? Check-in underscore city. Just the word spelling. Check-in city. We also need, so we need revenue, right? So our dot revenue, right? And then we're dividing it by days. So divided by, but for the days now, we have days and we have half days. So r dot days, right? Plus r dot half days divided by 2. Remember what I explained? So each half day is divided by 2 of the full days, right? So we divide this. But now here's a slight challenge. And there's something to know, like when you're dividing, remember you cannot divide by 0, otherwise you get an error. Like that's an indeterminate number. So there's this function that's useful when you're dividing called nullif. I'm sure to be in the functions that Mehitabel just shared. So you can see it's not possible to cover all the functions just in class. So some things you will learn, as we do examples. So if you do nullif, you're saying if this null, return a null if this is a certain number. And in our case, it will be if it's 0. So if your r days plus your half days is 0, you want to return a null. So you know it's if it's 0, right? And you close that bracket. And remember, we can also round once again, just so we don't have an unwieldy number. So we're rounding. Okay, let me do that. So if we're trying to find revenue, right, we say we do revenue divided by the total number of days, right? And total number of days is just r days plus r half days divided by 2. So the half days you divide by 2. You understood up to there, right?
Yes.
Okay. Now, if you're doing a division, right? If under your r days you have 0 and 0, if you have 2 zeros, let's say, those 2 zeros summed is going to give you revenue divided by 0. Now, a number divided by 0 is going to give you an error, right? So this nullif is like an error trap that's saying if you have 0 in my denominator, return null. So it's make it null if, and the function is just null if. So return a null if r plus r days divided by 2, is a 0. So make it null if this is a 0. If you divide by null, you're going to have 0. But if you divide by 0, it gives you an error. So that's something to note when you're doing division. So always put this nullif to trap that 0 error, which is a very common error, right? So does that make sense? And then I'm just putting this round, our usual round to round up the numbers. Okay, thanks. So we can call this price per day, just to use the same term in the question. And all this is coming from where? From rentals as R. Right? Should be able to run this. Is it half day? What's the table called? I was making this small typos. Right, I put an underscore my half day, I think. Yeah, it's just half days together. Yeah, so you see what we have. So for each city, it has taken the ID of the person, taken the city for that person's booking. So it takes the booking ID, city, and then divides the revenue by the number of days to give you a price per day for that particular city. So already you can see that we're inching towards our answer, right? We're looking for price per day per booking per check-in location. So now we have check-in locations for each booking and the price per day, right? So now we're left with dealing with these other bits, average change. But so we close our inner city So now that we have the price per day, right? So what we just need to get now is what? To select, in this case, we want to get the car rate, like from car rate. We're going to get the city, so they want the final city. We're going to get the price per day, and we're going to get the regional price. So let's do that. So with all of this as this, we select. So now we can use car rate just to identify the table. We could have called that C or something shorter, but I'm just. So they needed per city. They needed price. But then they needed the average price per day per location. So where there are multiple regions, so look at this table now. It's not all unique, right? Multiple people could have booked Munich. So there's Munich here, there's also Munich here, right? So we want to get the average for each particular city. So we have to combine multiple cities, right? So to the average, what's that column we had? Price per day. Price per day. So we have the average price per day. We need to can give it a name. So let's say average regional or region price, sure. And we're taking all these from our table above. So from car rate. And then we're grouping by check-in city. So now, essentially, what we're doing is we're taking this and we're trying to group all the cities together and get the average price per day, because different people pay different amounts for different cities at different times of the year, let's say, right? So from car rates, and then we just group by check-in city. Right. So for this, we don't have conflicting columns, we should still be fine. What do we have now? Yep. So now we have check-in city and we have the average region price, because we've aggregated all the check-in cities together and we've returned the average region price. But you see with the division, it's like very messy. So once again, let's call on our round function. So we can round it to maybe 2 this time. Right. I know we want to do Power BI. We're running a bit late on time. I plan to have a hard stop at 9:15 for this assignment. But remember, when you're doing your average, it's just, I'm just going to complete these and share the code with Jumoke, and she'll send to you for you to check your assignment against. But this is the main things I wanted us to look at, like doing this as homework was, if I close the other one, was to look at like inner queries, to look at those nested queries that we looked at, right? Subqueries, which we've looked at, to see how to use our width in a practical example, which we've done twice now, to see how to do these divisions and with nullif and round, right? To look at some of these date functions like year, like month, and to see how you can combine year and month to have date keys that are integers. And also to just have a sense of queries that are a bit more complex, right? With some arithmetic and things. But what we'll do is not to take too much time, because I want us to go into the Power BI bit, I'll share some solution so we've done A and B. I'll share solution to C and to the second part of B. And then we can, if anyone has any questions, we can take it up in our class on Monday. But I'll let Maitabel talk a bit about the Power BI bit for 45 minutes. And at the end, I'll just show us what our project will cover. But I think at this point, I'm very confident, especially the kind of questions you guys are asking, right? Like, why are you doing this? What I see that people have followed, and your SQL skills should be intermediate level now. You just need to do lots of practicing, right? Lots of practice and questions and tough questions like this. Do it in groups, work on problems, and always come back. Like, we can give you some tips on how to go about the questions if you get stuck. And with your project, you also have, room to practice a lot of what we've learned, right? So, Mehita, I'll let you go into Power BI because of time. And then at the end, I'll come back and show us the project and what will be expected of the project. Mehita, are you there?
Yes, sorry, I'm here. So I just put two what's it called? Two data sets in the chat. Please let's download it. Let's download it because we'll be using that for our Power BI class today. I also we also downloaded, all of us downloaded our Power BI desktop yesterday, and so we're good to go. So please, if you have downloaded the data sets I put in, I'm just trying to open up my Power BI right now. 1 second, and then I'll share my screen.
Okay. I'm in the chat as well if anyone has any questions. Sorry, I know today is feeling like a very packed day, especially this week because you guys did a lot yesterday as well. But you also have the videos to go back to, right? If you have any questions, feel free to ask. Okay.
Yeah. Sorry for the delay. One moment.
I'm seeing that some people don't have Power BI MacBook Wahala. So, like, what I recommend, I wish I knew this earlier. I'd have recommended using Parallels Desktop. It's a paid service, but I think you can do a trial. I'll drop a link in the chat. If you can do that quickly, you can run a Windows OS in parallel with your MacBook and put your... Okay, you've used that. So why did you just share the solution? So is it working? Oh, you need to pay.
I've used it in the past, and I've even used the feature to backdate to get access. So I'm at the point where I had to pay to use Parallels.
Do you want to pay? Because I did like a 1-year subscription in my case, and yeah. Otherwise, it works. It helps me a lot with my Mac as well. So.
Okay. So you can also use, I think with that one too, you have to pay. So I have like a remote, a Microsoft remote desktop. And with that, I think you might have to pay, but I don't think it's so expensive, especially it depends on the space that you're using, right? It shouldn't be so expensive. But for now, yeah.
Sorry to cut you. I was typing the wrong thing severally. I used UTM, BIMI, and it works and it's free. So you can download it. Maybe I'll share the video that I used with you. You do have to
show it in the chat just in case other people need it as well.
Okay. I'll do that.
Yeah, that's great. Thanks. So please download quickly and follow up so that we build whatever we're building together.
Okay. So we'll try to be as quick as possible. We'll just cover what we can today and then continue on Monday. So how many of us have heard about Power BI before? prior to yesterday's class? If you have, you could just, okay. Your hand raised, your last question, your hand is raised to answer my question.
You asked the question.
Answer your question.
Okay. I just wanted to be sure. Okay, so what, in any way you can describe, what do you know about Power BI? What have you heard about Power BI? Sorry?
Visualization tool.
Visualization tool. Okay.
Star schema.
Star schema. Okay. Anybody else?
It's more like a big engine room, making analytics more less stressful. So it's already more like a system generated quicker version of analyzing data, saving time.
Mm-hmm.
Let's just use that.
Okay. I mean, basically, all the things that we've sort of said is kind of correct. So Power BI is a visualization tool. It's actually a business intelligence tool. So the term business intelligence is really just like the name suggests, right? A system where a process of getting insight or intelligence from the data for the business. So just think about it that way. So Power BI is one of the most popular BI tools. We have other ones. We have Tableau. We have Zoho Analytics. We have MicroStrategy. We have Google Studio, right? And very many others. So these are like the very popular ones. And Power BI is one of the most popular ones. It's very popular because it is of the free version. Of course, Microsoft packages in terms of the cost are one of the cheapest around. Right, so you get to see a lot of companies use Power BI, and a skill in Power BI is right now one of the most sought after skills in terms of reporting, because you don't even have to be in the analytics team to be able to, create your Power BI reports. These days, what a lot of companies are doing is you have people who are skilled in things like Power BI, Tableau in the business units, and they simply just tap into the centralized data warehouse or get data from, the IT team. And then they're creating their dashboards for presentations, creating their dashboards for executive meetings to get insight and things like that, right? Power BI, is cloud-based and is pretty much a self-service business analytics tool. And why do I say self-service? Because it's very interactive. One of the purpose or the whole ideas of Power BI is you create your dashboard, or you share and collaborate on your dashboards, and then people can go in, dynamically choose dates. I want to see information from this date to that date, slice and dice your data using Power BI. And then, of course, in terms of the visuals, it has, it has really exciting visuals. Some other visualization tools don't have, a lot of them don't have as much as Power BI, right? I think Power BI has one of the most inbuilt visualization tools, visuals, sorry. Okay. Another thing to note about Power BI is Power BI can connect to lots of data sources, right? So if you have paid attention to all we've been doing, you discover that there's a journey for your data. Your data goes through a journey, right? It starts off let's say from your application. Let's start from the application, from the individual. So, for example, I pick up my phone. I want to feel I'm going through a website where I'm trying to shop or buy, a retail shop website or a fashion store website. I want to buy a dress. I want to buy, some shoes, and at the checkout, it asks me for information for my first name, for my last name. It asks me for maybe my date of birth and some other information, key information. It also has the information of what I'm purchasing, right? And then my email, just some nice information. I input that data. What happens is that data is going to be stored in a database. Very many times, that database is what you call, like an OLTP. That's a transactional platform where all these things are happening. And then usually that data is extracted into something we call a data warehouse. I'm just trying to give high level, right? So it moves from data collection to the database. In the database, it moves to a data warehouse. The data warehouse is a place where you transform all your data from different sources in an organization in order to make it presentable for reporting, to present it in a way that you are able to present it. Now, data lakes are like data warehouses, right? Except that in a data lake, it's really just think about like the name, a lake where you just really dump your data, where you import all your data, right? Sometimes transformations are also done in a data lake, right? But usually you put you like dump your data as it is in your data lake, like a staging area, and then you do your transformation inside your data lake. However, your data warehouse, it's a process called ETL, where you extract it, transform before you load it into your data warehouse. That's a different thing altogether. That's more BI, more data engineering terms. So you don't really have to worry about that in a data analytics or data analysis.
And sorry, I just wanted to add, like, also, like with data lakes, you have like some of them feel like a big dumping ground as well. Like, for example, with your data warehouse, you have more structure. With your data lake, it's like even some data that you don't know what the final purpose for it will be yet, you still have a lot of unstructured data as well in your data warehouse and in your data lake versus your data warehouse. So data lakes are like massive and lots of streams of data just pouring.
Yeah. Okay, thanks. So for Power BI, back to Power BI, we have, I was giving you the string, right? And so you have your data warehouse, transformed, and then your business intelligence tool or your reporting tool is plugged into your data warehouse, to present your data in a way that is readable, provides insight, provides information, intelligence for decision making for the business. So that's really how it goes, right? Udrak is asking for a difference again between a lake and warehouse.
Yeah,
do you want to
put in the chat so I don't interrupt you.
Okay. Right. So for Power BI, we have different the Power BI, Microsoft has created it in different sections or different phases. So we have the Power BI desktop, where it's a free desktop application, right? And it works with Power BI service. But for the Power BI desktop, you can create your visualization on the desktop, save your work as a file, right? And you can then publish it to your Power BI service. Your Power BI service is a cloud-based service that users use to interact with each other, where you use to view your reports. That's where you're using collaborating. You want to share reports. You want to create subscriptions, right? Those are done in the Power BI service. Now, typically, you create your report on your desktop, publish it to the service, and in the service, you can share with other users in your organization, right? Now, with the Power BI desktop, you can't share You can't share the reports and you can't dynamically refresh your report. But in the Power BI service, you can do that. However, you can also create reports on the Power BI service, but that's really not what it's designed for. And so you discover that there are certain things you can't do on the service, like you can't create measures and stuff like that. But in your Power BI work in desktop, that's what is actually meant to create your reports. Okay. Now, so how it works in your with your Power BI is you create from your database, you connect it to your Power BI desktop, right? You create your visuals on the Power BI desktop, and then you publish it to your Power BI service or your Power BI report server, right? Most times you use your Power BI service, and then in your Power BI service, you're able to then share, right, with other users, and people can view it on their, of course, on their devices in terms of their laptops or on your phone. There's the application for Power BI application that you can use to receive on your mobile phones, on your tablets, and all other devices. Okay, so that's just a brief, small summary of Power BI. In terms of, I'm trying to hide this thing. Okay. So this is what your Power BI interface looks like. Here is your canvas, right? And then at the left-hand side of your desktop, you have the report view. This is where this is the view we are at, right? That shows your report. Here you have the data view. When you import your data into your Power BI, this is where you see the data view like a database, right? And here you have your model view. This is where you create relationships and model the different data sets that you have, right? Now, at the top here is very, very similar to what we have in Excel, right? If you look at it, you see that if you've used Power Query in Excel before, you discover that it's very similar. We also have Power Query within Power BI. We'll see that. So we have different functions here. We have the file where you are able to save your reports. You have the home screen, which is what we have here. Get data. We use this to connect to different sources. Everything here really is about data. This is just like you have like, if you see Excel workbook here, this is one of the data sources, but here is just like a shortcut for that. The SQL Server is also a shortcut if you want to take to the SQL Server. Here, if you want to connect to your data hub, this is if your organization has this already. And then you can create a new data set by inputting the data by yourself, right? If you want to create new content, you can do that here. So you can also connect, so all of these are data sources to Dataverse using SQL. And then if you've been using some recent data sources, you'll see them here, right? So all of this here is connecting to your data source. So here, you can use Power Query. Like I said, we have Power Query Editor embedded in Power BI, just where you have it embedded in Excel. And you can use Power Query here to transform your data, to connect, to prepare your data. If you want to do that, you just click on Transform Data, and then you can use your Power Query here to do that. Here, it shows our visuals, right? So you can add a visual. You can also do that here. At this point, you have like all the visuals here. You can simply click on them, or you can go through this place. And then you have a text box. If you want to add something, you can see more visuals. If you want to go from App Store, if you have some visuals in your files, you can do all of this. But this is inserting a visual, right? Now, this is calculations. You can do some calculations, create measures. All these will be grayed out until you actually have data here. you see you haven't loaded any data yet, so you can get data. So this get data, you can also do that from here. Also, you can do that from here. So this is same thing, right? All of this is getting data. So let's just quickly go get our data so that all the things that are grayed out here will begin to open up. Okay, so if you want to get data, if you click on get data, right? Okay, I think I have not 1 second. Let me see. So I need to do this because I'm in a different okay. So here, if you click on get data and you come to Excel workbook. However, if you want to see all the different places that you can get data from, so you see them here, that you can get data from so many data sources, from Azure, sales, even from Salesforce, right? Google Analytics, so many data sources. Power BI has one of the most robust data source connections, right? That we have in terms of the BI tools, right? You also have a lot of them that have so many, but I think Power BI has, because there are some data BI tools that cannot connect with some other sources, right? So you can see that you have so many of them here. Okay. So I'm using Excel. So, we are using Excel, so we could just simply do this. So I want to please click on the sales data, right? And then if you open this, this opens up for you, and then you can click on this. I hope we're working together, right? So this is what our data set looks like. If we want to do, if we're good with the data, right, we can simply just load it. But right now we want to do a bit of transformation on the data. We want to go to Power Query to do a bit of transformation. So I'm going to click on transform data. Now it takes you to the Power Query. This is the Power Query window. Has anybody worked with Power Query before? Okay. So in your Power Query, we know we're familiar with most of all these tabs here. We wouldn't be able to go through each and every one of them. Like for every single one you open, you see some tabs, right? And they're doing one thing or the other. They're doing some sort of transformation or the other. The beauty of Power Query is that you can really, really wrangle your data. You can do all sorts of manipulations with your data, right? Based on what you have there. Many times, if you can think it, you probably can do it. Just think if there's something you really want to do, you probably will be able to do it. But today we'll just let me show you. Okay, so first, before I even start that, you can see here that this at the side of our columns, you see the data type, right? So for example, this is an integer, this is a text. This is supposed to be a date, but it's showing as a text, right? So we can try and change it and come here and put date time. It's giving me an error, probably because of the way I saved that file. actually need to be able to change it. Okay. Is anybody else having this error when you try to change it to date?
Yes, same error.
Okay.
Cool.
It's because of the way I think it's because of the way I saved the Excel file, right? Because I wanted to use this as a date so that I can show you guys how the data works. Okay. I would clean it up and change it for you. But let me just show you how to create extra columns, right? Now, if I want to create an extra column, we could do this. So you could see. You just come to add column actually. So add column, and if you create custom column, right, you can define whatever it is you want to put here, right? You can define whatever the name of column you want. So let's say, we say year. So I want to extract the year, right? So if I come here, if I do this, right, and I click on OK. Now, so this is giving me issues because of my, let's see, it's here. Yeah, so it's not seeing that as a date, and so it's going to give me an error, right? So okay, Baby Solam, say you said create new column and use date and year function, registration date new. So the thing is, because the only way this would work is if the date is imported properly. So this date is not being recognized as a date; it's seeing it as a text, right? So that is where the issue is coming from. So this is what conditional column is. Conditional column, you're just putting it's almost like a case when statement. So I'm going to clean up the data set, right, and reshare to everybody, right, so that we can see how that works. But I'm just going to now show us how to create models. So by next week, I would clean up the data set. I think I don't really know. I need to check it to see why it's being imported as a text, right? Okay.
I just wanted to chip in something. I honestly don't remember so well, but I know this cleaning that you're about to do outside of Power BI can be done on here as well. I do know that there's a function that you can use to extract the date from that column, to extract the month, and to extract the year, but you have to have them in separate column. So you probably want that function calls out the year, and the next function calls out the month. But I don't remember. It's been a very long time.
Yeah, so you can pull out the year and you can pull out the month from a date, from a full date, right? So that's the function you. Sorry.
No, I just wanted to chip in. I get what you're saying, Maitaba, but we could, unless we do a text manipulation, if you go to split column by positions, Yeah, we can just use 0 and 27. So it's picking all the spaces already. So if you cancel out the 11, yeah, so that will split, take out the UTC, and I think it makes a date. So
All right. Okay. Yeah. Thanks then. Thanks.
the UTC
Okay.
was confusing the thing.
All right. Okay. Okay. So, yeah. So now that we have our dates, right? This is so we can see that this has changed. This is what we're trying to achieve, because we needed the dates to actually be. We needed the dates to actually be. What's the word now? To have a date icon, right? For it to
Recognize
be
that a date.
as a date.
Right.
Yeah. Okay. So, if we want to now add a column, so let's say we want to be able to, so ideally when you're dealing with dates in Power BI, one thing to note or to do usually to create a calendar table, or we will not be creating a calendar table. I could drop the DAX query to create a calendar table, right? So whenever you're working with a fact table or a table that has a date, the best practice is to create a calendar table where you connect your dates to, and then whatever visualization you're doing, you do that using your calendar table. However, in your calendar table, you have things like the month, the year, the quarter, the week, if there is a weekend, just in case whatever analysis you're doing, you need like those information. You want to do like a rolling average or stuff like that. So here, just to show us how to add a column, right? So this is what we're trying to do. So here, and then so here you see that it has extracted just all the year. So there's so many things that we could do, right? Like using your Power Query, you could extract the month, you could extract the hour as well, depending. And then in terms of any other cleanups that you may want to do, you can do that on Power Query as well. Yes.
No, I just wanted to add, like, with Power Query, there's lots of, like, if you highlight as well the green top, if you go to the head of each column, it will give you like a drop down that tells you a bit about, if you just hover, especially those ones that the green bar is not complete. I just wanted to show that number of missing columns and things.
Where?
Like if you just hover on, just go to a fresh one and just stay there, like don't click. Where it is supposed to show you like number of missing columns, number of percent. You need to be on the green bar, pointing to the green, like the very green. Yes. Just that green line at the bottom. You need your tip.
It's just my
because you're moving, like just stay on the ones that are not complete. Exactly. Do you mind going to the territory name, for example? So like this always helps me when I'm loading my data to just check at a glance. Are there errors? Is it empty? Is there missing values?
Yeah, I don't think we have anything that has missing values, right? For
you have missing values in territory.
And the territory name. Territory name
and territory ID. You see about 1% is less than 1% is empty. So same with the column split, like once you just click around. But yeah, like Metabel said, it's a really robust tool with lots of data around.
Yeah, like even like the truth is, like I mentioned yesterday, in terms of Power Query or Power BI, we just need to like get the basics right. There's so much, we cannot go through every single thing, and even there's nobody using the tool that probably knows every single thing in it. So for this class, we'll really just focus a lot. I mean, we have just 1.5 classes to learn Power BI, so we would try to do mostly the basics, right? Oh, okay. So yeah, let's go ahead and do this so that we can. Okay, so if we click on this, right, the data view, remember here we had our report view. If we go to the data view now, we can see our data, right? And at this point also, we can also add some more columns. So here you can create a column, right? So let's assume that we want to create, let's see, new column. So it's not only in the Power Query that we're able to add columns using the DAX. So the language that is used in Power BI is called DAX expressions, right? I don't know if I should say that it's not difficult. It can get complicated, but it uses the same principle mostly with macro that we have in Excel, right? So yeah, there's a bit more complication to it where you do some switch functions and stuff like that. But for basic ones, it's very similar to macro, where you have maybe some just the typical operators that we are used to, right? Okay, so let's say I want to extract month. And something very helpful that happens with Power BI is when you select a function, it shows you like how to the syntax to use, and then like what your result is going to be, which I think is very helpful many times. So let's do this. So with this, it's giving us the month in terms of like the number, right? So not the month name. I think we should be able to also add a month name if we want. Let me see. I think with the month name, if I remember clearly, you can only add this with, you can only add the month name in Power Query. So with this one, you won't be able to add the month name, but let me see if I'm correct.
I think for you to get the month name in the function, like the dates function, how you want to call out the year. Okay, it's Ian.
Sorry?
Not to worry, you're good.
Okay. So yeah. So typically if you use, for example, like if you type a month or a date value, right? So let me just do this again. If you type a date value like the registration, right? Because it already knows that it's a date. It gives you options. So is it the day you want? Is it the month? Is it the month number? Is it the quarter number, or the year, right? So if you want just the month name, you can click on month and then you get that, right? Okay. So what again? You can concatenate, so you can merge stuff together. You can use a substring. Substrings are functions you use to split values, right? So for example, if I want to remove, the way I see large lanterns, I want to only take the large part, right? So, or I have maybe a first name and a last name, and there's a standard in the company that everybody's email address is the first name dot the last name. I can concatenate it together, or I have an email address and I want to split it to get the first name and the last name, right? You can do all of that using your DAX right here, right? Okay, and then so let's try to get our second one, which is the sales target. So my sales target is just a short table that gives me territory ID, name, and then the target for the year. If I load that. Okay, Cynthia said you got an error in the year column. Was it at the Power Query level or when you imported it to Power BI? Or are you good now?
I don't know which one is the levels of the Power Query. Just the way you run to get this year after you changed this the date time. So when I did it, it was just showing error all through that column. So I don't know.
Okay. So you can right-click on it. A quick way to get to where we're coming from, and just click on Edit Query, right? If you go to Edit Query, you'll go back to Power Query. So here, what we did was this is the what we wrote. So date dot here, and then your column. So is this what you have? If you followed me back to this point, is this what you have here?
Yes. Did you put another bracket, or this bracket came when you clicked on the registration date as well?
So when you click on it, you have the one with the square bracket, and then I'll close the bracket with the normal curvy bracket.
Oh, okay. I'll try that again. Thanks.
Okay. Okay. So now I have the two tables. For whatever reason, I can rename my tables. I want to rename my table. So I want to call this sales target. And then okay. So if we we've looked at the reports. I mean, this is where we're going to create the visuals that we're going to work on, right? And then here we've looked at our data view. There are certain added columns that we can add to in our data view. You can also always come back here to check if you have any errors, to see where the problem is coming from. You can filter. Just, like Excel, based on so many things, right? And then So if we go to the model view, right? In the model view, here we have two tables. Power BI has dynamically, or is trying to be smart enough to sort of create this relationship for me, right? So you can come here. Usually when you import your tables, right, it will try to create like a relationship between your tables. And so for this one, just look at it like a join, where you have the left joins and your right joins and stuff like that. You're trying to relate these two tables, right, in a way that when you join them together, or when you're looking at one other table, like when you, how do I say this now? Let's come here. So if, for example, you have this table, which is your sales table, right? And your sales target table is this table. Now, if you come to sales and you save for Northwest Port Local, if you want to know the target, right, you need to come to this table to check Northwest Port Local to see the table. So we need to be able to join on a common key, right? Just like we did in our SQL, we need to be able to join on a common key. Here, we have a common key, which is territory ID. You can also use the territory name. Usually, it's easier to join things on IDs because then they're just cleaner. So here, because the names here are the same, Power BI has thought that, okay, the best thing to join on will be IDs, but ideally I want to join on name, but ideally I want to join on the IDs, right? So I can, what I did was I double clicked on it, right? And then I can come here to change that. So if I click on the territory ID and I click on the ID here, so I want to join the territory ID at registration with the territory ID in the sales target. And then it's telling me that it is a many-to-one relationship. So you have different kinds of relationships. You have the many-to-one, you have the one-to-many. One-to-many and many-to-one is basically the same thing, but flipped, just the way you have the right join and the left join flipped. One-to-one relationship means that, okay, so many-to-one means that you have, here you have it in a unique way. So just one SL4 is going to be mapped to multiple SL4, or many SL4s are going to be mapped to one here. Many SL2 will be mapped to one here. So what it's saying is that you have a many-to-one relationship. And then one-to-many relationship is just a flip, right? Depending on where you have, which table you have first. So if sales target was going to be here and sales here, it will be one-to-many. And then one-to-one relationship is where you have a unique number, like the unique value here is also a unique value here. And so it's just mapped one-to-one, right? And then you have many-to-many. Many-to-many relationships are where you have, usually for many-to-many relationships, it could get a bit complicated because your data can explode, right? Where you can now have your data getting duplicated values because one thing, right, or multiple of the same thing is mapped to another table multiplied. So you're going to have like an exploded table. However, there are situations and there are cases where you also use your many-to-many relationships and they're fine, right? So just so that you know the different cardinalities. Cross-filter direction is just saying, do I want to filter from sales to target? So do I want only sales information to be able to filter through target, or do I want both? It's a good both ways. So if I select, say, the territory name from here, it's going to be able to filter everything here. If I select territory name from here to filter everything here, what do I want it to? I say I want both, right? So apply security filter, like the filter in both directions. I can click on this. And then I click on OK. And so if I come and I hover around here, first of all, you see that the direction changes. It's showing that I can filter like in both directions. And if I hover around here, it highlights the two columns that I've created my relationship with. Here, if I click on this, I can put some sort of description. Maybe someone comes into my PBX file, my Power BI file, and doesn't understand whatever tables, he or she can see whatever description I've put in. Here I can also add, if I come here and click on this and I put a description, maybe say this is my primary key. Anytime I hover on it, I would also see that, right? So just some sort of like documentation. And so if I hover around this, it shows me that this is my primary key, right? So, yeah. So yeah, our time is gone. We've imported this data, right? And so our next class, we're just going to create a few visuals using the data that we have, right? Does anybody have any questions? I know in terms of, I know I'm saying a lot that we're not going deep into the Power BI, and I'm saying that because I know that there's a lot that we could do with Power BI, but we really just want to understand, first of all, the foundations. This is like the foundations of Power BI. And then because there are different levels of Power BI expertise. And so at the end of this class, we want to at least have the basic foundation of Power BI. That's why I'm skipping through a lot of the details in terms of what we could do. But for our next class, we're going to create a few visuals, and then hopefully afterwards we can build on that in the future. But for now, does anybody have any questions?
I just wanted to chip in that we pay attention, right, to this data model, because you'll be using in your project, right, to visualize the relationship between the different tables. And I guess this is the right segue to talk about the project a bit. If no one has questions, that is. So if you have a question, please feel free. Otherwise, I know we're over time. I just want to introduce like what the project will be about, because you're going to be getting it tomorrow. Anita, any final things you want to?
No, I'm trying to stop sharing, really.
No, I can just share.
Okay.
Okay. So for the group project, I'll just quickly.
Sorry, quick one. The Shekinah, thank you again for all you're doing with my tabel. I appreciate it. If you don't mind, I sent a message to the session manager. If you can just open up that and just make it a Google Doc / a Word document, so that I can at least put the platform disclaimers on it before sending them out. I appreciate it. Okay.
Sure. Yeah, I already told her. I just wanted to show the text, but not sharing it till like Jumoke will send it out tomorrow.
Okay, that's fine. I just need her to send that to me so that we can clean it up.
Yes, but I will work on the Google Doc.
All right. Okay, that's fine then. Okay, that's fine then. Thanks.
Okay. So I'll just talk about this briefly. You get the document later with details on the homework and the data sets and all of that. But just to say, first, the purpose of the project, right? So we've spent a couple of weeks together. We started with some introduction to statistics, where we got introduced to how to apply statistical analysis to data science, right? To data analytics, how to think about tying the business problem to the data and structuring your approach, right? We talked about lots of things about how to do data analytics, like more soft things. And we went on to look at hardcore statistics, and all along we've been, saying how to apply it to business problems. So now the project helps us tie in all of that. So things we learned from the statistics portion, Excel, SQL, and now the Power BI session we're on, right? So the project is really important to really, tie in all these skills and tying all the knowledge together. And so the project is meant to be a group project. So we're going to be divided into 2 groups that will be communicated to you as well by the administration. Also, it will be, and it is, which we're going to discuss the case now, but high level, you need to develop business outcomes, solve a bunch of problems, and present it. So we're going to have a presentation session on Thursday of next week. So the expectation is that we finish all our analysis, come up with our recommendations, and have all those, in a small deck that will be presented on Thursday, right? So the deadline is kind of Wednesday midnight. And so what the case is kind of streamed down a bit just because of time. But there's a company, Ride-On, right, which is a wholesale distributor and has lots of different resellers and wholesalers within their network. And they cater to bikes, components, and clothing. So accessories for people in biking sports. And the goal is to improve operational performance, right, on different dimensions. So we're providing lots of data from the firm that talks about products, shipping, different resellers and their sales performance in different regions. So there's lots of different angles like each team could take the analysis to, right? So just looking at the data, the firm's objective is to analyze past performance on products sold, demographics, so among what groups of customers, and geography as well, and also any insights you can get on customer behavior from the data. It's all in there in the data, right? So the goal here is to understand or try to understand what factors might be affecting product sales or employee performance or wholesaler performance. So it's left a bit open-ended so that the team can also discuss and take what their approach would be. But ultimately, you're trying to look at the historical data, get some insights, some business insights, get some trends, starting from exploratory data analysis. You remember the first material we shared? That kind of helps you, give you a guide on how to approach this kind of data analytics project. So you explore the data, you try to visualize it, you come up with trends, you come up with the historical picture, like looking back, what has happened so far, and all the data will be provided for you to be able to do that. And ultimately, you would have to build your database, like all the data will be provided as CSVs. We've seen how to put a small database together. We've done it in the SQL class over and over. So you put that together and come up with a bunch of SQL queries that query that, said database that would also be part of your submission, right? And ultimately, each team has to develop what tangent they want to explore, helping the company improve their performance on. So some people may want to look at what regions are we doing poorly in, or have we historically done well in, and now we're not doing as well. Some people may take a different approach and see how individual wholesalers are performing, in different product subcategories, right? So you can slice and dice the data in different forms and come up with your approach, leveraging any tool, Excel, SQL, and Power BI for your final part of your final output of the project. But in all to say, make sure we're setting up the database, we're doing some SQL coding that will be part of the submission, and there'll be a Power BI dashboard and a small presentation deck of a few slides, somewhere between 6 and 8, right? That'll be presented on Thursday to a panel. Now, the project will be judged on your business relevance of your approach. Does it make sense? From the data you're seeing, able to get the right insights and draw the right conclusions? What insights can you get from the data? and also how you're able to communicate. And we would have the opportunity to get some feedback on some of like the softer, but yet very important things, how you're presenting, how you're showing your data, and how pragmatic and relevant are your recommendations, given all the data analytics work you would have done, right? Just to rush this a bit. So this is the data we're going to have. We have a couple of dimension tables. So remember we said fact tables are like capturing events, right? And so for example, a company selling things will be your sales. And the dimension tables are sort of descriptive data on different things. So there's dimension table that holds all the different geographies where Ride-On operates. There's dimension table on customers. There's dimension on employees. This will have information on employees, resellers, and so on, currency, product, lots of different tables. So it will expect us to draw a data model, a schema. Remember that relational database schema that we looked at in class a couple of times, where you have a table and it's connected to another table based on your primary key and foreign keys. And that's why I said the Power BI part where we're looking at the data model is useful to come up with that view, right? So you can connect all these tables with those lines showing the relationships. So that's important to help you understand what your data is and how it's connected. I'm providing both CSV and Excel files. Make sure you look at the data to make sure it's clean first. You may need some transformations, some extra columns you want to create. And finally, there's some guide on the analysis. Because of time, I won't go too much into this, but I'll maybe mention a few things on it on Monday. And so throughout the project, like you get support if you get stuck at any point and need some help with anything. Isabel and I will provide some support along the line. And also we need to try and have everything ready by Wednesday night. So thankfully, I think in some places it's a long weekend, so we can get time to work on the project. And this really helps you like have that team work and also make sure all the things we're learning, we're able to tie it in. And this is the kind of work, right, that you'll be able to do like on the job. So we want to make sure we're tying all together. So yeah, that's it about the project. Jumake will be communicating more and sharing the data set, and this, make sure you read this really well to understand the scope. And if you have any questions, feel free to ask. Yeah, so that's it. We've stayed over time today. So we'll see you on Monday. And please make sure you're already reading the project and exploring the data from tomorrow when you receive it.
Also, before you guys leave, just to let you know that for the purpose of this project, you have a totally different group. So it's a different group from your usual 6D1 and 6D2. So you have group 1 and group 2. So you won't have the same set of people in your former group in this new group, just so you guys would know.
Yeah. Before we go, just to encourage the class, like I'm really, impressed with